Hello, welcome to questions 6-4 to 6-9, starting chapter 6. Question 6-4 is going to relate back to what we just did in the core questions. 6-4, Sam collected data by measuring the pencils of her classmates. She recorded the length of the painted part of the pencil and its weight. Her data is shown on the graph at the right. On part A, it wants you to describe the association between the weight and length of the pencil. Remember to describe the form, direction, and strength, and any outliers that you might have. So if you see the direction here, this is increasing, so this is a positive direction. The strength is pretty strong. The points seem to be pretty well connected, except this one over here, which is an outlier. So we'll talk about that. And then also, the form of it is linear. Okay, so we're going to put all that stuff together to make sure that we're describing the association correctly. So I wrote as a strong positive linear association with one outlier at about 2.3 is what sort of looks like there. Okay, on to part B. Make a conjecture, a guess about why Sam's data had an outlier. Now, you can write really whatever you think in terms of why there's an outlier. It could be a human error. It could be maybe a shorter pencil, but maybe it's thicker in terms of width. Maybe she switched the coordinates around, or he switched the coordinates around. Or no, it says she. She switched the coordinates around or something like that. So there's a lot of different possibilities as what you could possibly put there. Once again, we're just making a conjecture about why Sam's data had an outlier. All right, for part C, Sam created a line of best fit. W equals 1.4 plus 0.25 L, where W is the weight of the pencil in grams and L is the length of the paint on the pencil in centimeters. What does the slope represent in this context? So first off, what is the slope? The slope represents, in that equation, 0.25. So that's the slope. Now, what does it represent? Remember, slope is the change of y, or in this case, the change of your weight over the change of x, or the change of length of paint. So think about that. How would you say what the slope is, 0.25, based on the change of y weight and the change of length of paint? Think about that. Now, one thing that might help is that your slope is divided by 1. So the length of the paint is going to increase 1 centimeter, then the weight will increase 0.25 grams. So you got the change of the length of the paint and the change of the weight. So I wrote that as the weight of the pencil will increase 0.25 grams for every 1 centimeter increase in length. Part D. Sam's teacher has a pencil with 11.5 centimeters of paint. Predict the weight of the teacher's pencil. So if we're going to use the equation W is equal to 1.4 plus 0.25 L, where W is the weight of the pencil and L is the length, then we want to know what the weight is. So we'll say W is equal to 1.4 plus 0.25 times the length, which was 11.5. So if you plug that in your calculator, what do we get? 4.275. So once again, if we want to predict the weight of the teacher's pencil, we're going to predict 4.275 grams. And so once again, make sure you answer that question, not just leave it in that equation form. And it looks like we have one more left to answer. E, interpret the meaning of the y-intercept in context. So the y-intercept is the 1.4. So the y-intercept, and remember, think about this as an ordered pair, 0, 1.4. 0 being your x, which is the length of paint in centimeters. All right, and then the weight would be 1.4. What does that mean? Well, if we're saying that we're not saying the pencil's gone, we're just saying that the length of the paint is at 0 centimeters, so there's still a pencil there, but it's so short that there's no paint left, that it'll approximately weigh 1.4 grams. And so once again, a pencil with no paint left will weigh approximately 1.4 grams. Question 5. Given the sequence 7, 11, 15, 19, what kind of sequence is it? So we're looking to see what the pattern is. Looks like we'll start off by adding 4, and it looks like that does stay constant, so that does mean we are looking at a arithmetic sequence. Define the sequence explicitly, so we want to give the equation that clearly defines what this sequence is, and we can find any term number. So there's two things we need. We need to identify the starting value and the rate of change or slope for this one, or the generator. So we know that we are adding 4 each time. And then the starting value at term 0 is what? Well, we got to work backwards 1. So if we work backwards 1, we're going to subtract 4 and get 3. So at term 0, it is 3. So therefore, our explicit equation would be T of n is equal to 4 times n plus 3. So that's the explicit. We could plug in any term number we want and get the end result. For C, is 109 a term of the sequence? If so, which term is it? So we're going to plug in 109 for T of n. That's the term in the sequence. And we're going to see if n is equal to a positive whole number. If it is, then 109 is in the sequence. If not, then it would not represent a term in the sequence. So I get 106 is equal to 4n. 106 divided by 4. 4 doesn't go into 106, but I'll figure out what the value is. Let's see, we got n is equal to 26.5. So it doesn't go in as a positive whole number, so therefore 109 is not a term in the sequence. So 109 is not a term in the sequence. And since it's not, which term is it, we don't need to answer because it's not a term. So we just want to know that 109 is not a term in the sequence. Question 6. Solve each system using the method of your choice. So starting with question A, we have 8y minus x equals 1 and 10y equals x plus 5. So we could use substitution or elimination on this one. I'm thinking maybe elimination. I'm going to subtract the x to get the x and y's on the same side. So that'd be negative x plus 10y equals 5. And then I'm going to take my other equation and I'm just going to rewrite it. I'm going to put the x first. So it's negative x plus 8y equals 1. So those are my two equations that I'll be using where the x and y are on the same side and they're equal to the constant. So it looks like I need to take one of my equations and multiply by a negative 1 so I can get the x's to be opposite. So I'm going to rewrite the first equation, negative x plus 10y equals 5. And then the next equation, I'm going to multiply by negative 1, so that's 1x, or x, minus 8y equals negative 1. The x's cancel, leaves you with 2y equals 4. Divide by 2, and y is equal to 2. And now we can plug that back into any of the equations we have so far. I'll go ahead and plug it back into the first one. So 8y minus x equals 1. And I will plug the 2 in for y. So 16 minus x equals 1. Subtract the 16, that gives you negative 15. And then divide by negative 1. And we get x equals 15. So your x value is 15 and your y value is 2. So your solution, remember, this is where the two lines intersect at the point 15, 2. All right, let's take a look at B. Once again, I think I'm going to set this one up for elimination. I'm going to add the 6x to this side. Actually, you know what? Let's go ahead and do, since we already did elimination, let's do substitution on this one. I'm going to solve for this value of y by adding 2x to both sides. So y is equal to 2x plus 10. I will now take that y value and plug it in for this part of the first equation. So instead of 5y, it's going to be 5 times what we're going to substitute for y, which is 2x plus 10, is equal to 2 minus 6x. Now, it doesn't matter which method you use. I just wanted to make sure that you saw both of them in this video. So I distributed the 5. Now we get the variable term on the same side by adding 6x. 16x plus 50 equals 2. I'm going to subtract 50 to both sides. So 16x is equal to negative 48. Divide by 16, and x is equal to negative 3. And now we can plug that negative 3 back into your equation, y equals 2x plus 10. So y is equal to 2 times negative 3 plus 10, or y equals negative 6 plus 10, and that's 4. So x is negative 3, y is 4. And once again, that's the intersection of the two lines. Question 7, simplify each expression using only positive exponents. So back to exponents. We are multiplying on a. I'm going to go ahead and expand this one out so you can see exactly what's happening here. And this is all multiplication. Even though I have the parentheses there, I could get rid of them. It's all multiplication. So we have 3 times negative 2, which is negative 6. We have x to the first power, because that's the only x there. And then we have 1, 2, 3, 4 y's, so that's y to the fourth power. So without expanding, you add the exponents. And remember, this is a 1 when you don't see the exponent on both the x and the y on the second one. B, we have once again x to the third, y to the second, times x to the negative second, y to the negative second. We only want positive exponents, so we could deal with the negatives by doing the reciprocal, but let's go ahead and combine them first by addition. So we have x to the third times x to the negative second, and then we have y to the second times y to the negative second. So let's add the exponents. 3 plus negative 2 is 1, and 2 plus negative 2 is 0. Remember, anything raised to the 0 power is 1, so this is really just x times 1, or just x. Okay. Moving on to C, we have division now. We have 6x to the negative second divided by 3x squared. So once again, we could move the x to the negative second to the denominator. Let's just go ahead and keep it the way it is and simplify from there. This is 6 divided by 3. So 6 divided by 3 is 2. And remember, when we divide, we're going to subtract our exponent. So it's x negative raised to the negative 2 minus 2. So that would be equal to 2x to the negative fourth power. But we cannot have negative exponents. We can only have positive. So we're only going to move what is being raised to the negative power. And that's just the x. So it'll be 2 divided by x raised to the fourth power. Okay. And the last one, D. We have negative 2x raised to the negative third power. And so since that whole thing is being raised to the negative 3, we're going to have to move it to the denominator. So now it's 1 over this whole thing, but now it's raised to the positive 3 power. And so now if you think about expanding it out, this is negative 2x times itself 3 times. And so that's equal to 1 over negative 2 times negative 2 times negative 2 is negative 8. And then x times x times x is x to the third. Normally we don't write the negative in the denominator, so you can either put it out front the fraction or in the numerator. But it's still 1 divided by 8x cubed, and it is negative. Question 8. Solve each equation for the indicated variable. So these are not going to be solving for values. We're going to be solving for variables, and there's going to be an expression left over at the end in terms of whatever variable you're solving for. So A, you're solving for x. So we have y equals 3x plus 2. So we want to solve for the variable that they asked for, which in this case is x. So we're solving for that variable right there. So what do we need to do? Well, we got to subtract the 2. We can't mess with the 3x until we subtract the 2. So that's y minus 2 equals 3x. Now, because it's 3 times x, we can divide by 3. And so we can divide each term by 3. We can divide the whole thing. X is equal to, you could either write it as 1/3 y minus 2/3, or you might have had it as everything was divided by 3. So y minus 2 divided by 3. Either one of those would be perfectly fine. On to B. So A is equal to B over C. We're solving for B. So if B is being divided by C, we can undo that by multiplying both sides by C. So we have AC, or CA, doesn't matter. And then the C's cancel, and that's equal to B. So you're done. It's one step. B is equal to A times C, or C times A. Either way would be fine. On part C, x divided by 2 minus 7 is equal to y divided by 3. We are solving for x in this case. So we're trying to get this by itself. We can start by adding 7 to both sides. X divided by 2 is equal to y over 3 plus 7. And since x is being divided by 2, we can undo that with multiplication. We're going to multiply by 2. But since there's 2 terms on the right, we've got to multiply the entire thing by 2. So that'll leave us with x is equal to, I'm going to distribute the 2. So this would be 2y divided by 3. Taking this 2 and multiplying here. And then the 2 times the 7 would be 14. And that is it. So x is now solved for 2y divided by 3 plus 14. And the last one, D, we have g is equal to 1/2 AT squared. Now we're not solving for just t, we're solving for t squared. So we just want to get that by itself. If we just want to get rid of the fraction, we can multiply by 2, and that would be 2 times g. And then that 2 would just cancel out the 1/2, and that's just equal to AT cubed, or squared, I'm sorry. And then now, since we're solving for t squared, we can divide by a, and t squared would be equal to 2 times g divided by a. And we don't have to solve for t. We're only solving for t squared on this one. So t squared is equal to 2g divided by a. Question 9. Find the missing term in each sequence. So we're going back, looking at our sequences, arithmetic, geometric, possibly, or maybe something else. We're looking for that pattern, though. So if you look, you're going from 1 to -7, so that would be subtracting 8, and then -7 to negative 17, which would be -10. So at first you might think, well, this isn't arithmetic, but then maybe you realize, wait a second, over here I'm going by 4 and then by 5. That's not at a constant rate, and then by 13 here. So something's not working out here. So what we need to do is we need to actually figure out if this is a linear sequence or arithmetic sequence by seeing if there is that constant change. So we're actually going to find the rate of change for the first 2 points, which I already showed you, but I can show you again. So this would be the change of y, which is in this case t of n. So that would be the delta t of n over delta n. And so that's 1 minus -7, which would be 8. And then 1 minus 5. So this would be 8 divided by -4 or -2. Okay? Now, is that same thing going to occur between these two? Well, we're going to take the 0.5 -7 and 10 -17, and your rate of change would be -7 minus -17 divided by 5 minus 10, and then this would be 10, because this would be plus, divided by -5, which is -2. So the rate of change is -2. Our slope is negative 2. And we check that by finding the slope of the three sets of ordered pairs between two of them. So since we know the rate of change is negative 2, I mean, we could write an equation. We could just add negative 2 over and over again all the way up to 23. Since we kind of already have almost everything we need, we do need term 0 if we're going to use the equation. So we work backwards, add 2 onto that, and give us 3. So the equation would be T of n is equal to negative 2n plus 3. And if I want to know what term 23 is, we'll just plug in 23 for n and solve that. So T of 23 is equal to negative 46 plus 3. And negative 46 plus 3 is negative 43. So it seems that this term right here should be negative 43. Now, you might have been able to figure that out a little different than what I did, and that's perfectly fine. That's just one way to look at it. On B, we have 10 that is going to 18, so that's plus 8. And then 18 to 32.4 is definitely different than 8, so it's not going to be arithmetic, and these are going up by 1. So if these are going up by a constant of 1 and these are not, then we know it's not arithmetic. So maybe let's look at geometric on this one. What do we multiply 10 by? 10 times what gives us 18? Well, if you divide by 10, you're going to get x equals 1.8. Now, does that hold true? If I take 10 times 1.8, what does that equal to? 18. If I take 18 times 1.8, now here's where we're going to see if this really works. So take 18 times 1.8, what do you get? 32.4. So we are multiplying by 1.8 each time, which is our generator or multiplier. We don't need to write an equation because we're already looking for the next term. So we can just take 32.4 and multiply it by 1.8 again. And you will get a value of 58.32. So there's a couple of ways you can figure out the missing term of a sequence, whether it is arithmetic or geometric. Now, once again, this one is geometric. And then this one up here is arithmetic.